Hello everyone. In today's session, you are going to learn about the normal form of the matrix and the PAQ form of the matrix. Both these forms are used to get uh, the rank of the matrix. Okay, can be used to get the rank of the matrix also. So first we'll start with the normal form. So what is a normal form? The normal form is nothing but a matrix which is in the diagonal form, a matrix which is in diagonal form, but all the non-zero diagonal elements are only one. In particular, I will give one example, then it becomes more clear. First of all, I will tell you another definition of the normal form. Every matrix can be expressed in one of the following normal form. And which are that? First one is say IR 0, or it may be IR 0, or it may be IR 0, 0, 0, and the last is just IR. So every given matrix can be written in one of these four forms, and that these four forms are known as a normal form. All these four are the normal forms. It depends on which order of the matrix we are given, we get that normal form. So just I will do one thing here. I will give one example, then it becomes more clear. So these four matrices, or these four are the normal forms only. So when this form we get, when the matrix is of this type of the order, say suppose you have the matrix is 1, 2, 3, say 1, 2, 3, and then you have say just I will take a simple numbers 2, 3, 4. Suppose this is the matrix. If you convert it in the row echelon form and then you convert that in the normal form, this matrix will be converted as 1, 0, 0, 0, 1, 0, and you will observe every time you have to separate the block of the identity matrix. If we separate this block of the identity matrix from here, this is say 1, 0, 0, 1. So the normal form we get here as the normal form we are getting here as I2 0, I2 0, and whatever the 2 we are getting, this is the rank of the matrix. So in all these four normal forms IR, we are getting the block of the identity matrices, and that block is known as so the order of that identity matrix is the rank of that matrix. So this is the example one. So if you come to the next example, so here if the matrix is like this 1, 2, 3, 2, 4, 6, something like this. So I have a mistake here. Let I take here 2, 3, 4, something like this. And if you convert that in the normal form, the normal form will become 1, 0, 0, 1, and this is 0, 0. Again, if you separate, if you separate the block of identity matrix, the dotted line you can draw here. So you get I2 block on the top. So the normal form will look like here I2 0, I2 0, this way. So whenever you draw this dotted line is actually separates the block of identity matrices. So here it is I2 and it is a block of 0. So I2 and 0. So this is I2 and 0. This 0 indicates there is a block of the zeros there. Okay, that may be of any type there. So that about the second example, when you come across the second type of the normal form. The third example, if I take it here, so I will take the matrix like this 1, 2, 3, then minus 1, 2, 1, and I will take here say 0, 4, 4, something like this. Now if you convert this matrix to the normal form, the normal form will go like this 1, 0, 0, 0, 1, 0, and 0, 0, 0. So this will be your normal form. What happens when we separate the block of identity matrix? So here we should have that dotted line, and here is another dotted line. Now this will convert into four blocks. One of the block is I2, other three blocks are of 0. So this normal form will look like I2 0, 0, 0. So this will be the normal form for this third example. And let I give you the last example here. The last example, if I take it here, say I will take a very simple 1, 2, 3, 4, something like this. If you convert this into the normal form will look like this: 1001, and that will be there is no separation. It is itself a block of identity matrix. So you get I2 matrix, identity matrix. So in all these four cases, I given the examples where the rank of these matrices is a 2. Okay, so what is the most important thing? Given a matrix, it may be square or rectangular. It can be go in one of these 1, 2, 3, 4 forms, and where all these four forms are considered as a normal form. Now, second question may comes in your mind: how to get these normal forms? Obviously, we can get the zeros. We can get the zeros in the matrices by using the row transformation as well as a column transformation. So step number one, suppose this is the matrix you are given. What is step one? Use A11 only, use A11 and make below it 0 by using a row transformation. What we are going to do it, always remember, if you go with some systematic way, you can easily get these normal forms. First step, convert the given matrix in the row echelon. Means use A11, make below diagonal zeros. So R2 minus 2R1, R2 minus 2R1, you will get this 0. After that, after that, once you get a row echelon form, yes, you have to move to, with the help of that A11, make after diagonal zeros using a column transformation. Okay, generally use a column transformation, make these zeros. And at the end, suppose the diagonal entry is other than 1, just divide by. Suppose this entry is a 4. So what you can do it, C2 upon 4 or R2 upon 4. So you will get this form. You will get the normal form. We'll do this with example, then it becomes more clear. So I'm going to show you two examples for the normal form. We'll do it one by one. Okay. So come to the question now. Here is the first example. The question is uh, the question is reduce or find the rank of the matrix by using a normal form. See the order of this matrix. Order of the matrix is 3 by 4. So let the given matrix is A. Okay, let the given matrix is A. We are going to use elementary row operation to make it in the row echelon form first. So we'll use A11. With the help of A11, our aim is to make these two zeros. Okay, so we get a new matrix now where the transformation is obviously to make this 0 is R2 minus R1. Only we use a diagonal element. R3 minus R3 minus 3R1, that is the next transformation. So matrix A becomes equivalent to this matrix now, 1, 1, minus 1, 1. First row as it is. These two zeros we want. See, R2 minus R1 is there. Minus 1, minus 1, minus 2. 2 plus 1, 3. Minus 1, minus 1, minus 2. Come to the last here. R3 minus 3R1. So 1 minus 3, minus 2. 0 plus 3. Yes, 3. And 1 plus 3. You will observe 1 minus 3, sorry, it is a minus 2. So that about step number 1. Next step, yes, we are going to focus on now A22. With the help of A22, we are going to make below it 0. Just we are proceeding to the row echelon form only. So our transformation is say R3 minus R2. Very simple transformation, R3 minus R2. So first row as it is, no change. Second row as it is, no transformation on it, but the last row becomes a 0 here, is it? So actually we got the rank of the matrix here only because this matrix is in row echelon form. All the elements below main diagonal are 0. We can say the rank of this matrix is 2, but the question is not by row echelon, question is by normal form. So our aim is to convert this in the normal form. Once we achieve this row echelon form, remember the next step comes, we have to make the zeros after diagonal. So this is the first row A11, and we have to make after diagonal means we have to make these three zeros now. Our aim is to make these 3 0 with the help of column transformation. So this is again a very simple. This is again a very simple. Just use a column transformation and make these zeros. So you'll observe this is a C2 and we have to use this position. So we take the C2 minus C1. C2 minus C1. Not only that, C3 plus C1. You will get this 0. And lastly, C4 minus C1. So these are the three transformation I used here. So 1 0 0 as it is. Obviously these three zeros we get it now. Because of that only we done this transformation. Because of column 1 is these two entries are 0, so there will be no effect on the remaining entries. So this will remain as it is, no change. Now we'll focus on this C22. So there are two ways now. With the help of this C22, we can make these two zeros, or we can make this as a 1 first, because in normal form we require non-zero diagonal element as 1 only. So see, this is the zero diagonal element, so we are not worried about it. But this is a non-zero diagonal element, so we have to convert this as a 1. So simply we can take C2 upon minus 2 or R2 upon minus 2. When you do R2 upon minus 2, you have to divide here also. So better use C2 upon minus 2. So the next transformation, I will do it here, this side, and here by C2 upon minus 2. C2 upon minus 2. So first column as it is 1 0 0 0 0. Now this is C2 upon minus 2, so this become 1. 3 minus 2 as it is, and remaining entries are also as it is. That's one, so simple. Now it is very simple thing that you have to do it. Use A22 now and make after diagonal 0. So whenever we have to make after diagonal 0, only column transformation. There are only column transformation. So we'll come to this last step here, where we have to make this 0 with the help of A22. So C3 minus 3C2. C3 minus 3C2, and last transformation C4 plus 2C2. That are simple things that we have to do it. So we get 1 0 0 0 0 1 0 0, and lastly 0 0 0 0. That is the end of the normal form. This is the normal form. You'll observe this is the matrix where only diagonal entries are non-zero, and that non-zero diagonal entries are 1, and that is our normal form. Here we have to make a partition now. Let us separate the block of identity matrix. So here is a separation. So what is the normal form we got here? So this is equal to, this identity block is I2 we got. The first block is I2 here. Here is a block of zeros. So I write 0. The third block, this 0 0 is also one more block. So that is a 0. And this is also the block of zeros. So this is 0. So the normal form is in this form, I2 0 0 0. And that is the normal form of the given matrix, where the rank of the matrix A is a 2, and that is the end of a question. We got the rank of a matrix by a normal form. I hope you understood this by only one example also, but quickly I will show you one more example for a normal form. So here we'll move to the second example, little lengthy because it have a number of more elements there, but it's not so difficult. Again, it's very simple. Now our aim is to make the diagonal element as 1. So later on, either you have to do that that C1 by 2 or R1 by 2. So it is better to interchange. You will observe uh, it is there is a 1 is available. So 1 is available in the first column or first row. You can interchange and make it the diagonal as a 1. So that is always allowed. Row and column transformation always allowed in the normal form. So let us assume the matrix is A, and now this A becomes equivalent to a matrix where we use a R12 only by R12. So we are interchanging the rows. So 1 minus 2 minus 4, then 2 3 minus 1 3 1 3 minus 2, and the last 6 3 0 minus 7. That about step 1. We are focusing on the first column. Use A11 to make these three zeros. So a simple transformation we require here, and that transformation will be R2 minus 2R1, R3 minus 3R1, and R4 minus 6R1. That's one. So here is 1 minus 2 minus 4. These three zeros we want. That is only our aim. So here is R2 minus 2R1. So 3 plus 2, 5. Minus 1 plus 4, 3. Minus 1 plus 8, 7. Come to the third row now. Here is 1. Is it? 3, 1. Correct. So R3 minus 3R1. So 1 plus 3 is a 4. 3, 3 plus 6 is a 9. Then minus 2 plus 12. Minus 2 plus 12 is a 10. That's one. Last, R4 minus 6R1. So 3 plus 6, 10. 0 plus 12 is a 12. And minus 7 plus 24. Minus 7 plus 24. You will observe that is a 20 minus 3. Is it 17? Check. Okay, if you do one silly mistakes in calculation, your rank may be changed and you get wrong answer. So you should be careful. You should be careful for doing this. Now we have to focus on the column 2. We have to focus on the column 2 and below diagonal. So yes, with the help of this entry, we can make these two zeros. So the transformation that we have to decide again here, the transformation that we have to decide. So I'll just make here partition. So the matrix become equivalent to now. So you'll observe this is the 0 we want. So we'll multiply by 5 and multiply by 4. So 5R3 minus 5R3 minus 4R2. 5R3 minus 4R2. And lastly R4 minus 2R2. R4 minus 2R2. That way. So the first row as it is 1 minus 2 minus 4. Next row, yes, these 3 zeros we want only. Second row there is no change. 5 3 7. These 2 zeros we want, because of that only we done this. 5R3 5R3, that is 45. Okay, it is 5R3 is a 45 minus, sorry, yes, 45 minus 4R2, that is 12. 45 minus 12, it is 33. Is it correct? So next, here is the calculation. 5R3 is a 50. 50 minus 28. 50 minus 28, is it a 22? Yeah. Similarly, come to the last transform. R4 minus 2R2. So 12 12 minus 12 minus 6. Yes, 12 minus 6, that is a 6. Is that correct? And here 17 minus 17 minus 14. 17 minus 14. So that is a 3. See, check the calculation. If you've done one wrong calculation, everything will go wrong there. Okay, just I will check one more time, because so previously we have here 3 1 3 minus 2 6 3 0 minus 7, and we done R4 minus 6 R1. R4 minus 6 R1. So this is a 3 minus my see, this is the mistake we done here. R4 is a 3. 3 plus 6 is a 9 here. So this is the silly mistake. If you do this type of the mistake, yes, everything goes wrong, and whatever the ranks you are getting, that is also wrong. So here is my mistake. Just I will correct it quickly. So little bit time will increase for the video now. Okay, so don't do these silly mistakes. See, we have R4 minus 6 R1. R4 is a 3. 3 plus 6 is a 9. So that's the thing we want. So 0 6 R1, it is a 12. That is 12. Minus 7. minus 7 plus 24. Minus 7 plus 24 is 17. The others are correct. I think that 9 is only wrong, and because of that the majority of the mistakes we done there only. So just a minute. So I will correct this transformation. So this is the wrong thing that we done. Actually, the transformation for the this row was correct. So we require, there is a 5r3 minus 4r2, 5r3 minus 4r2, and here for last 5r4 minus 9r2. This is the last. Okay, so the upper is different, 5r4 minus 9r2. So this is the different one we want. 5r4 minus 9r2. 5r4 means 60. This is 5r4. 60 minus 27. 60 minus 27, and that is coming 33 again. You can check. And lastly, here 5r4 means 17 fives. 17 fives are 85, minus 4r2 means minus 28. Sorry, minus 9r2 over there, minus 63. 85, 85 minus 63, 22 only. Same numbers are coming. So that is the step 2. So we made the zeros in the column 2. Now we focus on A33. With the help of A33, we have to make this 0. Very simple transformation we require. The matrix will become R4 minus R3. R4 minus R3. So 1 minus 1 minus 2 minus 4. First row as it is, 0, 5, 3, 7, 0, 33. Sorry, 0, 0, 33, 22, and last row is 0. So that about the step 3. This is the row echelon form. Right now it is a row echelon form. We got the rank of matrix also 3, but we have to proceed to the normal form. So we have to make after diagonal 0. So we'll fix A11. With the help of A11, we'll make after diagonal 0. So very simple transformation, and generally this always helps us. uh, See, after diagonal making 0 is always simple. So we have to take C2 plus C1 to make this 0. C2 plus C1, C3 plus 2C1, and C4 plus 4C1. And this is the way you can get 3 zeros there, 1, 2, 3. So these 3 zeros are here also. Remaining entries, no change. Now just we'll focus on A22. We can make this 1, and very simple transformation by C2 upon 5. By C2 upon 5, you will get that matrix. Okay, there is a lack of the space, so I will erase this first part this side. Okay, so let I check whether I can write it for at least this one. 1 0 0 0 0 1 3 7 0 0 33 22, and last row is 0 0 0 0. Yes, one of the step I managed here. Okay. So let I write last 2 steps this side. Okay, only 2 steps are required there. So still it is not in the normal form, because in the normal form we require the diagonal elements as 1 only. Non-zero diagonal elements require 1, and it should be a diagonal matrix also. Now our aim is to focus here on column 2. With the help of this A22, we are going to make these 2 zeros. So a simple transformation that we require here. So matrix becomes equivalent to, see, we take C3 minus 3C2, C3 minus 3C2, and lastly C4 minus 7C2, and you will get 1 triple zeros, 0 1 0 0, and here are 2 zeros, these are two zeros, only this 33, 22, these only left. We focus on this now. So a simple transformation to make it as 1. Yes, guess. It's better always for column. So C3 by 33. If you take C3 by 33, 1 triple zeros, 0 1 0 0 0 0 1 22 0 0 0 0. And the last step now, the last step, use this one to make this 0. So the last step that we have here is C4 minus 22 C3, and we get the final answer here: 1 triple zeros, 0 1 0 0 0 0 1 0, and lastly 0 0 0 0. So here is a partition. The partition of this is this side. Here is a partition again, and this is the normal form that we got. So let I write in short here this normal form as, see, first block is I3 there, I3, another block is of 0, this is 0, this is 0, and this is the normal form, and the rank of this matrix is 3. That is the end of a question. Yes, it's a lengthy example, I accept it is lengthy, rare chance, very rare chance to come in the exam, but yes, the logic is mainly important. Whenever we want a normal form, if you proceed step by step, there is a zero chance of having the mistake. Better you always fix that echelon form. Step 1, convert the matrix in the echelon form. That means below diagonal 0 by using only row transformation. Use a row transformation to make below diagonal 0. After that, use column transformation to make the zeros after diagonal. After diagonal. So you will easily get this normal form. So that about your first article of this session, that is a normal form. Yes, one more article I'm going to cover here of this session only. It is a PAQ form. Now, in PAQ form, this is the first step that we should write. Whenever you are given the matrix A, we write the equation I into A into I. Remember, for any given matrix, A, we can write it as I into A into I. But if this matrix is not a square matrix, suppose it is of order m by n, the first matrix should be of order m and last should be of order n. So if matrix A is of order m by n, just start with Im A In. So these are the identity matrices. Now to get the PAQ form in the normal form, what we are going to do it? We are going to apply row and column transformation on the LHS matrix so that this LHS become a normal form. This is the normal form. There is a property of the row and column transformation. Whenever you apply row and column transformation on the equation of matrices, remember every row transformation you have to apply on the first matrix only, that is Im only. Every column transformation you have to apply on the last matrix only, that is In only. The middle matrix A remains unchanged, no change in that. So automatically when you apply all the row transformation which you are applying to the LHS side, so you will gives you the matrix P here. This middle matrix remains as it is, there is no change on it, it is A. When you apply all the column transformation on the last matrix, it gives you the matrix Q, and automatically you will get PAQ, the multiplication PAQ in the normal form. Now what are the properties of this matrices P and Q? Remember this P and Q are always non-singular matrices. So determinant of P and the determinant of Q is always a non-zero. This is the property. They always becomes a non-zero only. Okay, automatically they becomes a non-zero. So it is just a repetition. It is just a repetition of normal form only. Only the extra part that you have to do it on the right hand side. Apply every row transformation on Im only, every column transformation on In only. So when you apply all column transformation, you get the matrix Q there, and for every row transformation, you will get the matrix P there. So that is the extra part there. So we'll understand this with example. Let me do one example, then it becomes more clear. Okay, so these are the same steps I said. apply row and column transformation on LHS so that the matrix A becomes a normal. Every row transformation will make change in the first matrix only, and every column transformation will make in the change in the last matrix only. That's one. And we get, so another important thing, remember, these matrices P and Q are not unique. Different person can use a different transformation, and because of that the matrices P and Q are not unique. But remember, they are always a non-singular matrices. That is only the property of this P and Q. So we'll do one example, then it becomes more clear. So suppose this is the matrix we are given and we are interested to get in the PAQ form. We want the matrix P and Q there. So just I will note down this matrix and then we'll move to the slide there. So I will just note down the matrix here only. The matrix we are given. Okay, just a minute. 1, 2, 3, -2, 2, -2, 1, 3, 3, 0, 4, 1. That is a matrix given, and let I show you how to do it. Okay, so we'll start here. Suppose this is the matrix A we are given, and our aim is to get the PAQ form for this matrix. So first you should see the order. There are 3 rows and 4 columns. So given, you can start, let the matrix A is of order 3 by 4. So you can start with I3. This is the first row, A, I4. Let the matrix A is written in the form of I3 into A into I4. So here is a matrix A. On the other side, you have to write I3 1 0 0 0 1 0 0 0 1, the matrix A, and then I4 1 triple 0 0 1 0 0 0 0 1 0 and 0 0 0 1. So this is the identity matrix of order 4. So this is a third order identity matrix, fourth order. So nothing new now, just focus on A11, make zeros below it using the row transformation. So transformation will be R2 minus 2R1, R3 minus 3R1. That are the transformation. As these are row transformation, they will make change in the first matrix on the RHS side only. We'll come to that also. 1, 2, 3, -2. These two zeros are there. R2 minus 2, R1 is there. -2, -4, -6. 1, -6, -5. 3 plus 4, 7. Okay. I will come to here. R3 minus 3, R1. So 6, 4, -9, 4, minus of 9, is it -5? So I will come to this part also. R3 minus 3 R1, it is -6. See, R3 is a 0, -6, that -6. Do not, so it is 1 plus 6, 7. That's one. That is on the left hand side. On the right hand side now, we are said the row transformation will only affect to the pre-multiplied matrix only. So make a change in only first matrix. So 1 0 0 as it is. R2 minus 2 R1. So this one. R3 minus 3 R1. So this one. So now there is no change in the last two matrices. A as it is and I4 also as it is. 1 triple zeros. 0 1 0 0. 0 0 1 0. Triple 0 1. That's one. Next step. We are interested to make the LHS in the row echelon form first. So for this, yes, we'll focus on A22. With the help of A22, our aim is to make this 0. A very simple transformation by R3 minus R2. So you'll observe the matrix will remain 1, 2, 3 minus 2, 0, -6, -5, 7. These three zeros as it is. The left hand side, again this is the row transformation. It will make in the first matrix only, make the change in the 1 0 0, minus 2 1 0. There is a change in third row because it is R3 minus R2. So minus 3 plus 2, minus 3 plus 2 is a minus 1, minus 1 1. That's one. A as it is. This matrix no change again. 1 triple zeros, 0 1 0 0, 0 0 1 0, and lastly 0 0 0 1. That is the row echelon only we got here. Remember, our aim is to make the LHS, this matrix, left hand side matrix, to the normal form. Then only we get a PAQ form. So here we are going to focus on A11, and using a column transformation will make after diagonal 0. After diagonal 0. So we have to make these three zeros using the column transformation. So the next step I will write here on the top side there. So just decide the column transformation first, and the transformation will be C2 C2 minus 2 C1, okay, by C2 minus 2 C1, C3 minus 3 C1, C4 C4 plus 2 C1, C4 plus 2 C1. So these are the column transformations we require, and the matrix will become now 1 triple zeros, 0 minus 6 minus 5 7 0 0 0 0. So this is the change that we have in the LHS. RHS now, as these are column transformation, there will not be a change in the first matrix. It's as it is, 1 0 0, minus 2 1 0, minus 1 0. That's one. The matrix A as it is. Now here is a change because these are column transformation. It will make in the change in the last matrix only 1 0 0 as it is. Now it is a C2 minus 2 C1, minus 3 C1, and plus 2 C1 that way. And it is 1 0 0 0 1 0 0 0 1. So remaining elements as it is. So we came up to this step. We came up to this step. Now the next step, here you can make it is 1 first, and then you can make the zeros. Yes, if you make it this one, you make it here a fraction number. Okay, you make it. So choice is your. You can divide this by minus 6 and then make zeros. That is also okay. Choice is your. Choice is your only. So I'm going to focus here to make this as a 1. So my transformation will be by C2 divided by minus 6. C2 upon minus 6. So I'll just erase this. So the transformation is, I taken C2 upon minus 6. C2 divided by minus 6. So the matrix that we get 1 triple zeros, 0 1 minus 5 7, and this 0 0 0 0. This matrix 1 0 0, minus 2 1 0, minus 1 minus 1 0 A. Now I taken here 1. See, now this makes little complicated because you are divided by 6. So the number comes in the fraction. So if you can avoid these fraction numbers also by taking like 6 C3 minus 5 C2 that way. So that is also good. But this we decided to divide by 6. So that's okay. Minus 2 upon 6, minus 2 upon minus 6. That is 1 by 3. This is a minus 1 by 6. And this is 0 0. Minus 3 2 0 0 1 0 0 1. Up to here is fine, I think. Last step, the last step of the PAQ form, focus on A22, make after diagonal zeros. Focus on A22, make after diagonal 0. So by C3 plus 5C2 and C4 minus 7C2. That is the last step, and we get the final answer here. So for that, yes, We require little space, and just I will erase this. That's one. Now come to the last calculation. You will observe this side 1 0 0 0 0 1 0 0 0 0 0 0. So that is LHS. On the right hand side, first matrix, yes, unchanged because no transformation. There is no row transformation. But yes, there is change in the last matrix now here. So first column, there is no change. Second column, there is no change. Yes, third column, there is change. C3 plus 5C2. Now C3 is a minus 3. So I'll write it here for you. C3 is a minus 3 plus 5 times C2 plus 5 by 3. 5 times C2, na? So minus 9 plus 5. Minus 9 plus 5 is a minus 4 by 3. So this is a minus 4 by 3. That because it is C3 plus 5C2. Now 5C2 minus 5 by 6. And here these zeros as it is. So that is for the third column. But C4 minus 7C2. C4 is a 2 and minus 7C2 means minus 7 by 3. So this is a 6 minus 7 minus 1 by 3. Then it is a 7C2 minus 7C2. So plus 7 by 6. 0 and 1. So that is end of the calculation. So these rough calculations were done. So I will erase it. And that is end of questions only. So you will observe mainly the left hand side is in normal form. If you make this partition, we get I2 0 0 0 equal to PAQ. What is a P? P is this matrix. This is the matrix P. This is the matrix P. This is the matrix Q. Now this P and Q are not unique. Remember, if you change some transformation, your elements will be different in matrices P and Q. There is one mistake I made from the beginning. I think you should note here. So this third diagonal element is 1. I made a mistake. You should check that. You should check somewhere. I made a mistake there. So that is 1 there only. So this is 1 there. That should be. Otherwise, what happened? This become a singular matrix. Why? Remember, there is one property. When the matrix are lower triangular or upper triangular, the determinant of the matrix is the multiplication of diagonal elements. So these are diagonal elements. So what is the determinant of this matrix? P is 1. Determinant of the matrix Q is 1. So I'm making mistakes actually. This one I missed here. This is 1 here. Okay. So 1 into minus 1 by 6 into 1 into 1. So minus 1 by 6 is the value of this determinant. So all they are non-singular matrices. So do not make the silly mistakes while writing, while you copying these matrices. So that about end of the PAQ form. So this is the matrix P, this is the matrix Q, and obviously they are always non-singular. No need to check it. No need to check it. It is very simple when the matrices comes as upper triangular or lower triangular. The determinant is a multiplication of diagonal element. Hence, we got the multiplication of 3 matrices P and Q so that this multiplication is in a normal form. That is a PAQ form. Okay. So thank you so much for completing this session. Yes, we'll move to the next article in the next video. So till then, yes, bye bye. Okay, thank you.